Okay, so now we want to talk about the difference between speed and velocity, and we're going to build on the definitions of distance and displacement that we developed in the previous video. So to start, let's define what speed and velocity are. Okay, so speed is just distance over time. Okay, so speed is just distance over some time interval. Right? It's just the distance that you travel over some time interval. Whereas velocity, on the other hand, is the displacement over some time interval. Okay? It can often be that same time interval. Now, in equation form, this would just be d over t, and this would be delta x over delta t, okay? And we often give the designation speed as s, okay? S equals speed or distance over time, right? And we usually give velocity the variable t. Now, I'm going to do something now that I did in the last video, and I'm going to draw these arrow figures over my velocity and my displacement. Now, what are these arrows? What do they represent? Okay. To answer that question, we have to talk about the difference between scalars and vectors. Now, a scalar is simply a quantity with magnitude. Okay, it's a measurement with magnitude. And your speed, okay, your distance over time, is just a scalar, and that's because your distance is a scalar. It is just a length. Now, your displacement, okay, your displacement is actually a vector. So displacement actually includes both the magnitude of your distance from your beginning to ending point, and it includes the direction at which your ending point points away from your starting point, okay? So if displacement is a vector, then that means that velocity is also a vector. And we will flesh out what a vector means and how to use vectors. But for now, just realize that any time I put an arrow over a quantity, that is going to be a vector. Now, what are some other examples of some scalar quantities? Okay, so if you think about it, what types of things only have a measurement? Okay. You might think of temperature, you might think of mass, you might think of volume, you might think of energy, okay? And all of these are scalars. So speed, distance, temperature, mass, energy. All of these are examples of scalars. Now, what about vectors? Okay, what about vectors? Well, we already know two. We know that displacement is a vector. We know that velocity is a vector. And we're also going to realize that there are several other very important vectors. The two most important vectors for our purposes are going to be acceleration and force. Okay, we're going to see that acceleration and force are vectors. There's one other really important vector that we're going to encounter later on in the course, and that is also momentum. Okay, now practically, what is the difference between using a scalar and using a vector? Okay, other than putting this nice arrow over the top. Okay. The main difference is that when you're working with scalars, we generally, it's good to define a coordinate system, but you don't absolutely have to. And particularly, let's say you're taking measurements of temperatures, okay? There's really no quote unquote coordinate system you have to define to take temperature measurements. Your speed is just what, for example, your speedometer on your car is going to read. It is just the value of your rate of change of distance over time is at any particular point. Okay, and again, mass is just the amount of stuff that makes up something. So that doesn't necessarily need a coordinate system to work with. A vector, on the other hand, because it has both magnitude and direction, we're going to have to specify coordinate systems, right? And we're going to have to be very careful in what our coordinate systems are, and we're going to have to be very careful in keeping track of our negative signs and so on and so forth, okay? So those are the differences between vectors and scalars, right? Scalar, just a quantity with magnitude. Vector, a quantity with both magnitude and direction. Now, let's do a couple examples here using speed and using velocity, right? So we're going to start with speed. And we're going to see that there are two basic ways to define speed, okay? We're going to talk about what the average speed is, and we're going to talk about what the instantaneous speed is. So we're going to define average speed. Okay, so to start, your average speed is just your total distance over some total time interval, okay? So average speed is total distance okay, over some total time, all right? Now, for example, let's say that we have a situation where we're taking a day trip, all right? Let's say maybe you're driving to the beach or something, and the beach might be several hours away. So you get up in the morning, you might leave your house at 8 o'clock, and you might stop for gas, you might stop for lunch, but also in between you're going to be going maybe interstate speeds of 70 mile per hour or maybe 75 mile per hour. So let's just come up with a scenario and calculate the average speed for a trip, okay? So for example, let's say you leave your house at 8 o'clock and travel let's say you travel 120 miles in 90 minutes and then stop for gas for 8 minutes and then let's make that 10 minutes. And then you travel, let's say, another 100 miles in, let's say 70 minutes. What was your average speed for the trip? Okay, and actually this should be an E. Okay. All right, so what we need to do is determine what the total distance we traveled was and the total time that it took for us to do so, all right? So we can see that we traveled for 120 miles and then we traveled for 100 miles. So our total distance would be 220 miles. Now note, we don't care, okay? I do not care at all what direction I'm traveling in. So I could initially be traveling north and then turn east, or I could be traveling south and then turn west. I don't care, okay? All I'm talking about is the distance. So my total distance is going to be 220 miles. So my total distance is going to be 220 miles. And the total time, I have 90 minutes plus 10 minutes plus 70 minutes. So I've traveled for 170 minutes. okay? If you want to, you could convert that to hours. That'd be just under 3 hours. And so if you take that quotient, right, if you take 220 and divide it by 170, that will give you your average miles per minute. And that includes, right, the amount of time that you stopped, because if all you're concerned with is when you left and what time you got there, then your average speed would represent the speed your car would have to be going constantly throughout the whole trip to move that same distance in that same time interval. Now, here's something about your average speed. Your average speed cannot be larger than the fastest speed that you traveled, and it cannot be lower than the slowest speed that you traveled, okay? And in this case, that's not really an issue because our slowest speed would be 0 when we were stopping for the gas, right? Now, let's contrast that with what we call the instantaneous speed. Okay, now your instantaneous speed is the speed you're going at a specific point in time. So again, this is exactly what your speedometer would be reading for you at any given moment in time. It is your exact speed at a specific point in time. Okay. So for example, if we were on our trip to the beach and we looked down at our speedometer, at any given moment it might be reading 70 mile per hour, it could be reading 90 mile per hour if we're trying to pass someone on the interstate, could be reading 40 mile per hour if we're on a back road to get to a gas station or to a restaurant. Your instantaneous speed is just the speed that you're traveling at a specific point in time. Okay, now we don't really have a nice formula the way we do for average speed, distance over time. We just say that this is the exact speed you're going at a specific instant. So in the next video, we're going to explore velocity, and we're going to define what average velocity is and what instantaneous velocity is, as well as define what acceleration is. So stay